Okay, let's get started. Thankfully, I got the projector working, so if you ever have a tech issue in the future, please remember, turn it off and on. Okay, are there any questions? Or is everyone just ready for spring break? Aren't we all? I call it my catch-up period. So are there any questions? No questions? Okay. So what did we talk about last time?
Objects.
Objects. So what are the things that we talked about with respect to objects?
Well, the alternative name, abstract.
Yeah, abstract data type. So the idea there was, as we've talked about last time, was it's a structure for putting a bunch of values together. So a bunch of pieces of data all in one convenient location, and then you define operations on manipulating that data. So the name kind of implies that there's not really a definition as to what an abstract data type is supposed to do. It just says, in general, you have a bunch of data in one place, and you define operations on it. So there's nothing really interesting about that. But a lot of the field is about abstraction. So instead of working with the low-level details about how something works, because then you may be bogged down in all those details, what you try to do is abstract away from that by thinking about the higher level aspect. So you have to think, okay, I'm going to be storing, let's just say, information about students. So you don't have to think necessarily, okay, I'm going to store a name and that type is going to be a string, then I'm going to store an ID and that's going to be an integer and a GPA, which is a double. You don't have to think at that level of granularity. You can abstract away and say, okay, for a student object or ADT, we're going to store information about the student, such as their name, age, ID. We're going to store information like that. But then we have to think, what kinds of operations do we want? Do we want information about getting the GPA of that student, like getting that piece of data out of the student, or printing all of the courses that the student has taken, or printing the transcript, or maybe for ASU, what is the currency here? No, not dollars. Sorry, M&G. I forgot. I went here and I forgot that. So maybe printing the M&G balance of the student, or things like that. You have to think about what things do you want about the abstract data type that you're considering. But in general, we're dealing with abstract concepts. We're abstracting away from all of the details, which we will get to in a bit. But we're abstracting away to make thinking about the problem a lot easier. So remember when we were talking about functions and modular programming, where we had this high-level idea, and functions allow us to break that idea into multiple little pieces so that we can focus on that high-level aspect, and once we broke it down into little chunks, then we can focus on the details of each piece, independently of all the others. Same idea here. It's a little more general than functions, because we'll be using functions here, but it's the same idea. You're trying to get away from the low-level details. So abstraction in general allows someone to design a solution to a problem without concern about how it's actually done. So you don't have to worry about the details. You just think about the high-level aspect, which is really nice. Advantage of software development. Yeah. So for the POW function, do you care what the POW function is actually implemented as doing? No, you don't care. All you care about is it's expecting the base and the exponent, and it's supposed to give you the number which is the base to that exponent. You don't care what happens on the back end, right? It doesn't concern you. So if we were worried about the details, then you would care about what's happening on the back end. But since we're not implementing it ourselves, we can abstract away all the details and just worry about the result that is given to us. So that's actually really important, not just in using a function like POW or square root or whatever, but when you design your own functions, you got to make it clear as to what is actually happening. So what inputs is it expecting and what output is it getting? So there was this great talk by Scott Myers, who is a retired member of the C++ community. You can look up this talk on YouTube, and I highly recommend you do. It's called The Most Important Design Guideline. The Most Important Design Guideline. So the idea there is, the guideline is, make interfaces easy to use correctly and hard to use incorrectly. So for the POW function, could it be possible that, so the first argument of the POW function has the base in it and the second one has the exponent. Could it be possible that someone messes it up and puts the exponent as the first one and the base as the second? It is possible. Am I going to get the same result? No. So in that case, I would say that POW is not really a good interface because it allows us to have the arguments in any order. But suppose, for example, the POW function is not like this. But suppose the POW function took a string as its first argument and an int as its second argument. So it forces a string as the first one and an int as the second one. Could I switch them? Could I put an int as the first one? No, why? Because when you compile, it says you can't convert an int to a string like that. So that would be a case of where you can't use the POW function in that case because you're doing it in a way such that the compiler automatically rejects when you're doing it wrong. So that's not always the case. So like in the real POW function, it takes two doubles. So if I switch the order, it's still taking two doubles, but it can't really enforce that you're doing it in the wrong order. So try to think about that when we're going to start making objects. But the point of this is to make the user of the interface or the function or whatever to not have to worry about the details. That's the key of abstraction. So abstraction is basically what we said. It has general characteristics, but it doesn't have all the details. So it just abstracts away from the details. Data types, we kind of talked about this for a while now, but basically it's just what types of things can you store? Can you store a numerical type like an integer or a float or whatever, or a string or something else? So it defines what things can be stored there. But we're going to be making our own types which have a bunch of values together. So maybe for like a student object or something, we're going to have a hybrid of data types. It's going to have strings for the name, age maybe for an integer, and then maybe their GPA, which is a float or a double. So when we're composing all of these data types together, we could have a hybrid of different types that can go together. So for a student data type, we can define the types that it can have are strings for the name, integer for the age, and a double for the GPA, as an example. And as well as the operations that can be performed. So we talked about this before. So the first bullet here, procedural programming, can anyone give me a quick summary of procedural? Because we've been doing it this entire class, yeah. Right, yeah. So it's essentially what we've been doing this entire class. It goes from the top of the main function, Maybe it goes off to another function, but its goal is to go from the top of the function to the bottom. Yeah, so it goes one statement after the other. Object-oriented programming, on the other hand, is where we're going to be focused on not this order anymore, but putting data into these objects and then manipulating the objects at our will. So we're going to be creating, for example, student objects, and then we'll create some students in our main function and then do some stuff with the student objects. So it's not that we're going to work from top to bottom anymore, but we're focused on the objects themselves, not on the procedure that we're trying to solve. So like on midterm 1, the programming questions had a bunch of procedures that you did. So like printing the Cauchy-Schwarz inequality, the difference between the two sides, that's a procedure. You input the values, it does calculation, it prints the result. Here we're going to make objects that represent something and then manipulate them at some later point. So you may be wondering, okay, what's this encapsulate word here? So it says, based on objects that encapsulate the data and functions, blah, blah, blah. So in order to do that, we need to talk about some terminology so that everything makes sense later. So I've mentioned this object thing a couple times. It's just an entity. So like a student or something we're trying to model. So, or maybe a classroom or a course or a university or a person or a car. Anything that we want to model, we can think of that as an object. So it's just a single entity that has a bunch of stuff in it. An object has two things. It has attributes, which are basically those data points that I was talking about before. So like a student has the attributes of their name, their age, and their GPA. Those are attributes. So you can think of that as actual values. So what values would you put into a student object? Those things are attributes. Another thing that they're called are member variables. Attributes and variables are the same thing here. But then, of course, when we're dealing with objects, as we've been talking about, we have various operations that we define on the objects. So like for a student, maybe print the transcript as an operation. So that is called a member function or a method. So those two words, those two phrases are the same thing. I probably will use the word method. Yeah, so it's just a function that acts on the attributes. So the print transcript would be look up in the attributes corresponding to maybe the GPAs of the courses the student took, as well as the names of the courses the student took, and print all of that information all into a string and print the string maybe. So, but of course, these functions can do pretty much anything. So we have to think a little bit about what functions are relevant to the objects we're going to be working with. Any questions on those first three or anything else before? Because these next two are kind of important. Okay, so what are these last two? So remember when I said that objects are a way of trying to put a bunch of values all into this one entity, so that when the user interacts with this object, they only see the object. They don't see they don't have to worry about all the details on the inside. So that's the idea of data hiding and encapsulation. So I'll talk about encapsulation first. So that's the idea of putting all these values into one place. Nothing really difficult to understand there. It's just you're encapsulating everything all into one place. Nothing hard to see there. Data hiding is a little different. So data hiding says that we're going to restrict access to the underlying members or the functions themselves, but usually the attributes of the object. So maybe, for instance, think about the GPA of a student. Do you want someone to create a student object, or maybe working with one, and say, I'm going to set your GPA regardless of what you did before, regardless of the classes you took, I'm going to set it arbitrarily to 4.0. Wouldn't you all like that?
Yeah.
Yeah, but think of it like from our perspective, the university's perspective. Would they want that? No, they wouldn't want you to arbitrarily have access or maybe write access to the GPA variable. So what you would do is you would restrict the access to that variable, and then you think, okay, well, how would I change that if I took a course? So if I took a course, got this GPA, how do I actually update my own GPA if I can't access it? That's where the functions come in. So what you can do is say, I'm not going to allow you direct access to the GPA variable, but I'm going to allow you indirect access by saying that I'm going to have a function which says, you took this course with this GPA, you can pass that into the function, but you can't access the GPA variable directly. The function itself is going to modify the GPA variable for you in the way that you would expect it to. So data hiding says that some variables you shouldn't access directly. Like if we're modeling a bank account, for example, you don't want access, well, maybe you do, but the bank doesn't want anyone to have access directly to the underlying balance of the account because you can just set it arbitrarily high. Whereas with data hiding, you can indirectly give access to it by saying, you can submit a deposit request or a withdrawal request, and then the bank will do the validation for you and update the balance for you. So it's basically an indirection from being able to modify the variable directly. Any questions on these two? Yeah.
Can the word members be interchanged with attributes? Is it the same thing?
Yeah, so the question is, can I interchange the word member with attributes? Yeah. I usually will say either members or member variables for the variables of the class, and then methods for the functions. But these two and the attributes and variables, those are interchangeable. Other questions? Okay, so let's talk about an actual example. So suppose that we're trying to model a very simple thing, a square. So you have to think about, when you're making this object, what data do you actually need, as well as what operations do you need? So my advice is to think about the object you're dealing with, think about the minimum possible amount of data that you need in order to know everything about the object. So in order to know everything about a square, what do you need to know? The side. Could I equally do the area instead? Yeah, so how do I find out the side from just knowing the area only? Find the square root. So note here, just because it says side here doesn't mean that area is the only way to, that side is the only way to go. There are other ways you can go. Could I store both the side and the area? Yeah, but now it's just if I update the side of the variable, now I have to update the area variable also. Because if they're not in sync, then we're in trouble. Question for you. Suppose instead of a square, we were doing a rectangle. So not just a square, but it could be a rectangle in general. Would area be enough for a rectangle? No, because I can have many different combinations of side lengths to have that corresponding area. So for a rectangle, I actually do need the width and the height and the width, for example. So you have to think about what is actually necessary for the thing that you're working with. So this is just a really simple example. let's just say we're going to work with side for now. Does it have to be an int in general for a square? No, not necessarily, because it can have a negative. It could have a fractional part. Could a side be negative? No. So is this type not right? Is there a better type than int? Yeah, what's a better one? Unsigned. Could a square have a side length of 0? I mean, technically yes, because it's just a single point. So, but it can't have negative side length. So you have to think about that. So just figuring out the single type of this one variable can have big implications. So do we want negative values or do we not want negative values? You have to be able to think about that. But let's just say that int really is the right type. Pigs have flown. We have negative side length on the squares. Spring break is here. But yeah, so let's just say that the variable's okay. What functions do we want to know? Well, because of data hiding, we're going to restrict access to the side variable here. Although it's not really important in this case, but it's good practice to have data hiding. So let's just say we hide this variable from the user of this object. Well, we want to know information about the square. We want to query the square and say, what information can I infer about you? So one example may be getting the side of the square, getting that variable out. So that's this get side function right here. Note, does get side allow us to modify the side variable necessarily? Do I have to modify the side variable here? I could if I wanted to, but I probably won't. The name get side here means get the variable, the hidden variable here, and return it to the actual user of the object. And we'll see an example of how this works. But this doesn't give direct access to the variable. It gives indirect access, which is kind of cool. What if I mistyped and I put int reference here? So I put a reference on the return type here. Do you think that would allow me to modify the internal variable? Yeah. So you have to think about the return types too. So this is the part of the class where we have to start thinking more about how to design it first before we even implement it. But of course, if we wanted to be able to modify the side variable, we can't modify it directly. So we're going to give you a set side function. So the set here, the name of the functions can be anything you want. So it doesn't have to be set side. It could be set side of square or set square or square set. You can have anything you want. But the name implies that you're trying to set this internal variable side length, the side here. So note that there's a parameter right here. What do you think this parameter is supposed to do? Right. So let's just say that the internal variable right now has a value of 5, and I want to change it to 10. So what should S be? If the internal variable is 5 and I want to change it to 10, what should S be? No, not a reference, but what value? 10, because I'm trying to set the side, this internal variable, with the one that's coming in from outside. So here's an internal variable I'm trying to modify, but I'm working over here. So I don't have direct access, but I can pass over the value I want to the function set side, which will do the manipulation for us. And then I don't have direct access to the variable, I have indirect access.
Is that like a default?
Yeah, you could put a default here. But if you're trying to use the set side function, you're probably trying to change it from something other than default, probably. But yeah, you could have a default parameter if you wanted to. So let's actually do an example. So I'm not going to do a square, but I'm going to do a circle instead. So we got to create a circle object. But first we have to think, what things do we want to store about a circle? The radius. Could I so let's just say circle, another word for member variables is properties, but I'll do variables. So let's just say radius is 1. Do we need to store anything else to know everything about a circle? Yeah. Circumference. Could I get the circumference from the radius? Yes. Could I store the circumference in addition to the radius? Yeah, but now we have additional work we need to do. If we want to modify one, we have to modify the other. But so if we wanted to know the circumference, we just look up the radius at a given point and then get the circumference from there. What about area? I can get it from the radius. I think that's all we could. What about suppose we took the circle and rotated it in 3D space to get the volume of a sphere. Do we need to know the volume? I can infer it from the radius also. So I think radius is all we need. So I'm going to do an example later, but it's better to show you actually doing this in real code. So how would you actually create a circle object? So there's a word that in C++ we haven't seen yet called class. So anytime you see the word class, that means we're creating an object. So if we want to create a circle object, we should create a circle class. Good. So the way you do this is you do class and then the name of the class you want to make. In this case, we're creating a circle. So I'm going to make a circle class like this. And you have to put, I think, a semicolon afterward. So note, the class here is outside of the main function. So, but like functions that we've seen before, classes are also outside of functions, for reasons we'll see in a bit anyway. Okay, so let's see. Do we have this? I might as well just teach it to you here. So think about, okay, so we need to think about the operations that we need to do first. So let's just do one really simple operation. Let's not make this complicated. What should be an operation on a circle?
Radius.
Or maybe let's just do get radius to make it really easy. So let's just maybe have a function called get radius, just like this get side function. Well, should I allow direct access to the radius variable? Well, data hiding says no, that's not a good idea. So the good thing about classes is that they hide things from the outside world by default. So I don't have to do anything special for the radius variable here, which is nice. So what type should the radius be? Should it be an int, a string, a double, or what? A double is probably a good option here. So although radii should not be less than 0 because of the same issue as with side from before. So we may have to do some additional work to say radii can't be less than 0, but let's not worry about that for now. But do I want the outside world access to the get radius function? Do I want someone else to be able to get the radius of a circle indirectly? Yeah, that should, because that's an operation we defined. So how do I actually communicate to the class here to say, I want this thing to be visible to the outside world? Because as I said, classes are private by default, meaning that they don't show things to the outside world by default. So the way you do this is something called public. So you say public here with a colon, and what public does here, we'll talk about all of this in a second, I swear. But public, all it does is says everything from the word public down until it says otherwise, that is exposed to the outside world. Okay? So we would want getRadius to be here. What type should getRadius return? The same type as the variable that we're trying to return, which in this case is double. So we should make a function that returns a double called getRadius. And we're going to actually put the full definition of the function right inside the class. So this is one reason why classes are not allowed to be inside other functions, because we're making functions inside of it. So what is this function supposed to do? It's supposed to get the internal variable radius and return it to the outside world. So what should this function do? Return radius. It really is that simple. Okay, so let's actually create a circle object. So how do I create a circle object? So instead of saying string s equals blah, 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 something like this, we're going to do circle, maybe let's call the circle C. And we're going to do something which I'm going to talk about in a few slides, but just bear with me for a bit. We're going to put parentheses right here, and we're going to provide the radius. So what's an example radius? 2, okay. So then what we can do is say, let's output the radius of the circle. So can I say cout c.radius? And what this would do is access the internal variable directly. Can I do this? No. And in fact, if I did this, it'll give me a compile error. So what I would need to do instead is call getRadius, the function. So this dot says, for this object, look up the getRadius function and return the value associated with it. And then let's do new line. So let's actually compile this. I hope it works. So G++ circle. Okay, so bear with me. Oh, yeah, that's right. So it's something called a constructor. We'll talk about that in a bit. Okay, so ignoring what I just did, if we run this, it actually prints 2. So what happens here is we're creating a circle object, and we're looking up one of the functions in this case. We're getting the value that's coming back from the function and just printing the result. So there's nothing really special going on here. We're getting 2, we're storing it into the internal variable radius, and we're calling the getRadius function, and it prints the result. Any questions on this example other than this part, which I will get to, I promise. Okay, so hopefully it shouldn't be too difficult to work with. Okay, so yeah, so why do we hide data? We kind of already talked about this. You don't want direct access to important pieces of data. But another reason is it makes it easier on the programmer. So if they only see like the getRadius function and don't see all of the internal data associated with it, now they have less that they need to understand about the class in order to be able to work with it. So as long as the functions do the right thing, the programmer shouldn't have to care. So that's basically what that is. So we kind of, I already showed you this. So if you want to create a class, you do class with the name after it and then stuff on the inside. So it's like a function, but without parentheses here. And then you create an object of that type by just saying the type, which in our case was circle, and then the name of the circle, whatever you want to call it. So here's an important thing. So being able to say this variable should be accessed outside or should not be, or this function should be able to access outside or not, you do those with access specifiers. So there are technically 3, but we're going to talk about 2 for now. We'll get to the third much later because it deals with a new concept we haven't talked about yet. So the 2 that we need to understand now are public and private. So classes, unless you say otherwise, are private by default. So private means the thing that is private is only accessible inside the class, but it can be accessed everywhere in the class. So it's not like a function anymore where the order of the functions actually matters here. In classes, it doesn't matter what order you put them. As long as all the pieces are in the class, doesn't matter what order you put them in. You can put all the functions at the top and the variables at the bottom, or the other way around. Doesn't matter. But if it's private, the thing that's private can only be accessed inside the class, but everywhere in the class. Public means accessed everywhere. So if you have an object of type circle, for example, and let's just say we looked at the getRadius function again, what type, was it public or private? The getRadius function. It was public. So I can, if I have a circle object hanging around anywhere, I can call getRadius on it from anywhere. It doesn't matter where that circle is created. Doesn't matter where the function is. Doesn't matter. I can call getRadius on it anywhere I like. So public means accessed everywhere. Private means you can only access it inside of the class. Which is why, if we go back to the example, this internal variable radius, it is accessed everywhere inside the class, but it can't be accessed outside the class. And in fact, if you tried this, if I tried to access .radius right here, which is accessing that variable, it will give me a compile error. Because it says that the variable is a private member of the circle class. And so I can't access it directly. But if instead I said, I'm going to move this radius to public, so I'm going to change its access, then this will be okay. And so now you have to think, well, should I have this thing be public? Should I have this thing be private? And it really depends on what you are working with. The vast majority of the time, for purposes of this class, is to put the data, the variables themselves, to be private and the functions to be public. Sometimes you cross the boundary, so to speak. Some functions become private, some variables become public, but the vast majority of the time, variables are private, functions are public. Yeah, okay. Yeah, the default is private. But you can have public and private as many times as you want. So you can have a public section, then a private section, then a public, private, public, private, as much as you want. Usually you put the private all in one place and all the public in one place, but you can do this any way you like. So here's an example. The private at the top is not necessary because classes are private by default, but it's just a good idea to put that there anyway. So this is almost identical to the class that we were working with, the circle class. We have some variable up here that's private and public functions down below. Okay, so let's actually modify our class a little bit. So the reason I had this right here, we'll talk about what this is in a while. The reason I have it is that we don't have any other way of modifying the internal variable because I don't have a set radius function. So what I'm going to do here is I'm going to actually make a set radius function, and then we don't have to worry about that anymore. So let's make our own set radius function. So remember, for a set function, it should take some parameter here, the thing that we want to change the internal variable to, and then we change the internal variable with the parameter that was passed in. And we don't return anything because all we're doing is setting a variable. We're not returning anything. And then here, I actually need to get rid of this for the reasons I'll talk about later. But then I can say c.setRadius 42, for example. And then here I can call .getRadius again. And then what should we expect to be printed right here? Print 42. So let's actually go through the motions of how this actually works. We create a circle object right here. We're setting the internal variable radius to be 42. So let's trace through this. 42 corresponds to this function right here. It corresponds to set radius because that's what I'm calling. So R here, right here, that is initialized to 42 because that's what I passed in from down here. Then, because this is 42, I'm setting the internal variable radius to 42. Note, is the set radius function inside the circle class? Yeah, so does it have access to the internal variable radius? Yes. But out here, where I'm calling set radius, does it have access to the internal variable radius? No. So that's why we have this function right here to act as an intermediary from the outside world to the variable we want to modify. So if we run, compile and run, we expect 42. What if instead I called set radius twice with 420? Don't laugh too much. What should be printed now? 420. So why is that the case? So the first time through I call set radius, 42 is passed in, and as we talked about, radius is then set to 42, no problem there. And then we call set radius again with 420, and so R is now 420. Regardless of what radius was before, it overwrites the previous value. So if we compile and run this, we should expect 420, and we do. So these work just like normal functions. There's nothing really special about these functions. It's just now we have access to the internal variable. Any questions on this example? Yeah.
I understand how it works. I'm kind of confused about the syntax with circle C and C dot set radius.
Yeah. Yeah.
C dot
Yeah. So you may be wondering, okay, like what is this dot and what is everything here? Yeah. We'll get to all that, but basically, we're creating a circle object right here. Oh, oops. And this dot right here is an operator. So like normally how with an integer type you can add integers together with a plus operator, dot has a special operator meaning. And what it means is, look at this object and look up the function. Call the function set radius of this specific object. So he raises a good point right here. What if I created a circle C2? So the name of the other circle is C2. And I call set radius to be 55 because I can't drive that fast. Anyone get that song reference? I can't drive 55. Anyway. So let's see. So I'm calling set radius right here. Is this set radius on line 30 right here the same set radius function as is on 26 and 27? They're not the same. Why are they not the same? They're different objects. So this dot operator, what it does is it looks at the specific object that it corresponds to, which is C for the first two and C2 for the second. Yeah. Yeah. So the question is, can I have multiple circles on the same line? Like that. So you can use comma just like before. There's nothing different there. Yeah.
How does it differentiate between C and C2? Do you need two different objects, two different classes?
So if you need two different circles, you need to declare two different circles, but you only need one class. So here, they're both circles. They may have different radii, but they have the same behavior otherwise. And so therefore, I can declare two circles on the same line. Now, if I wanted like a circle and a square, then I need to, first of all, initialize them on different lines, but also to have two different classes. Yeah.
Does the main function access the class by the keyword circle in this case? So,
Yeah.
like,
So,
what if you tried to name something else besides circle there?
good question. So the question here is main accessing the circle class? And the answer is yes. So what happens here is when you're compiling this program, the compiler has to figure out, okay, the main function is requesting to create two circle objects. So what it needs to do is look at the circle class and figure out how much memory is actually needed to create a circle object. Well, for what we need to know, the circle object, all it really needs to know is the radius itself. So it really is accessing the circle class. So if I'm creating, for example, a string, is accessing the string class. If I'm creating some other object, is accessing that class. It's creating something called an instance of that class. So think of it like this. So this is a great analogy. I've heard it many times, and it's definitely true. Think of a class as a blueprint for a house, and think of these circles down here as the actual house. Okay? So I can go from the blueprint as much as I want and create additional copies of that house, but the blueprint is still here. So if I wanted to create another house, I just go over to the blueprint and say, okay, blueprint, as if it were a person, what materials do I actually need to construct this house? How much wood do I need? How much man labor do I need to actually do this? So if I want a concrete, notice the analogy. If I want a concrete version of a circle or a house or whatever, then I need to look at the blueprint and figure out what I actually need to make it. So to answer your question, it does access the circle class. Yeah.
When you see out radius, does it do two radius? Oh, I see. Because you put in get radius.
Yeah. So good question. So I could, for example, do another one of these cout statements with C2 instead, and then if we printed this, it would do the two radii of the circles. So it's looking up the corresponding method of that one particular object. And yeah, so this dot operator ties together a single object with either a variable or a function. And it's all functions in this case, but it ties the object that we just made with something about that particular object, which is pretty nice. So if you wanted to model students in this, maybe in this room, for example, then I would create a student object for each one of you. And then maybe what I would do is say, I would set your exam score to be this, your exam score to be this. So then I would have a function like this student dot set exam score and pass in the exam score. And then this other student dot set exam score to be something else. So that should be a quick introduction to objects. Any questions?
Is that how you graded our exam? Like, did you do that?
That is precisely how I graded your test. Any other questions? No, I used the dartboard method to give you your scores. No, kidding. Any other questions? Great, I'll see you Friday.